So you've dabbled in Solidity, right? You've got the basics down. But there's a huge leap between a contract that works and one that's actually professional grade. We're talking cheaper, safer, and way more scalable. That's exactly what we're going to dive into today. Let's do it. Okay, let me just ask you this straight up because there's this one super common trap that I see developers fall into all the time. And I mean, this mistake can literally make your entire contract useless down the road. See if this rings a bell for you. But hey, before we can spot the problem, we gotta be on the same page. So let's do a super quick refresher on the basic anatomy of a solid Solidity contract. Think of it as our blueprint for what we're building. All right, so here's the skeleton, right? You've got your state variables, that's where you store stuff. You've got events, which are like your log files, modifiers, which act like security guards, the constructor, which runs once when you launch it, and of course, the functions that do all the heavy lifting. We're going to zoom in on a couple of these key pieces today. Okay, time to get to the main event. This is the mistake I was talking about. And the tricky thing is, it seems totally logical when you first think of it, but trust me, there's a ticking time bomb hidden inside this approach. So picture this. You've built a cool contract where people can store, I don't know, a list of wishes. Simple enough. Now your front end, your web app, needs to show all those wishes to the user. The big question is, how do you actually get that data out of the blockchain and into your app? Well, the first thing almost everyone tries is creating a function, let's call it get all wishes function. The idea is simple. The contract keeps an array of all the wishes, and when your app calls this function, it just loops through the whole list and sends it back. Easy peasy, right? Makes perfect sense. Yeah, no, that's a huge mistake. This approach is what we call an anti-pattern in the smart contract world. And here's the scary part. It'll work perfectly when you're testing it on your local machine. But out in the wild, on the mainnet, it is an absolute disaster waiting to happen. So let's break down exactly why this is such a time bomb. See, every single time a new wish gets added, that array gets a little bigger. And as the array grows, the gas required to loop through it also grows. It's a linear increase. Eventually, and this is the killer part, you'll hit a point where the gas cost to run that loop is bigger than the entire block gas limit. And from that exact moment on, your get all wishes function is bricked. It will fail every single time, forever. So if that's the wrong way to do it, what's the right way? Well, the elegant professional solution is something called Solidity events. Okay, so instead of making the contract do all that heavy lifting of gathering up the data, we use events. The best way to think of an event is like a broadcast signal or a little flare. Every time a new wish is added, the contract doesn't just quietly store it, it also emits an event. It basically shouts out to the world, hey, a new wish was just made over here, for anyone who's listening. And this is why it's such a game changer. Just look at the cost difference. It's staggering. Storing data in contract storage is super expensive. We're talking something like 20,000 gas for a new entry. But emitting an event, it's ridiculously cheap, like around 375 gas, plus a tiny bit for the data itself. You're saving a boatload of gas on every single transaction. So here's the key takeaway, the big aha moment. We're shifting the workload. Instead of making the expensive on-chain contract build that list, we let our cheap off-chain application do it. Our app just sits there, listens for all those event shouts, and builds its own list of all the wishes. This lets the contract do what it's best at, managing security and state changes. That's it. Okay, so we've made our contract efficient, which is awesome. Now let's make it secure, and let's make sure it can actually handle money. We need to talk about guards, gates, and, well, gas. First up, modifiers. You know, the best analogy for a modifier is a bouncer at a club. Seriously. Before your function is even allowed to start running, the modifier steps in and checks the ID. Is the person calling this function the owner? Are they on the VIP list? Do they have permission? If the answer is no, they're not getting past the velvet rope. Simple as that. And here is the classic example, the only owner modifier. You see that require statement? That's our bouncer checking the ID. It makes sure that the message.sender, the person calling the function, is the same as the owner. If it's all good, that little underscore you see there, that's the bouncer saying, all right, you're good, go on in, and the function code runs. If it fails, the transaction is stopped dead in its tracks. So what about money? How do contracts even receive Ether? It's actually incredibly simple. It's just one keyword, payable. When you mark a function as payable, it's like opening up a mail slot on your contract specifically for Ether. You're telling the entire network, hey, this function right here, it's allowed to accept money. All right, so we've covered efficiency and we've covered security. The last piece of the puzzle for a truly professional contract is knowing how to deal with things when they, inevitably go wrong. It's all about failing gracefully. When things do go south, Solidity gives you three main tools to handle it: require, assert, and revert. Now, you've already seen require in action with our modifier, but knowing when to use each of these is absolutely critical. So let's break down the two big ones. You want to use require for checking things that come from the user. Validating inputs like, hey, did you send enough Ether for this? Or, wait, are you even on the whitelist? If a require fails, the transaction stops, but crucially, the user gets their leftover gas back. Now, assert is totally different. That's for internal sanity checks, things that should be literally impossible in your code, like if your total supply of tokens suddenly went down. If an assert ever fails, it means you have a serious bug, and as a penalty, it eats up all the gas. I really love this summary here because it just makes it so clear. Think of it this way. Require is your contract telling the user, hey, you did something wrong. Assert, on the other hand, is your contract screaming, whoa, I did something wrong. Something is broken inside me. And revert is just the low-level tool that both of them use to actually stop everything. You see, getting these tools right isn't just about having clean code. It's about building contracts that are predictable, secure, and honestly, fair to your users. This is what separates the hobbyists from the pros. So let's recap. By ditching that nasty array loop, by using events to feed your app, and by putting strong guards and smart error handling in place, you are well on your way to building much, much smarter and more resilient smart contracts. But that kind of leads to one last thought, right? Your code might be perfect, but in the wild, chaotic world of blockchain, is anything ever truly unbreakable? I'll just leave you with that to think about.